Alright, so this is the last lesson for Unit 6. If you look at the bottom of the page, you'll see that Unit 6 is called Rational Expressions, and all I want you to remember, what does it mean for it to be a rational expression? You know that you'll see a division symbol, okay? And then when you have a division, you have a numerator and you have a denominator. So you'll have like a function in the numerator and a function in the denominator, rational expressions. And this lesson, lesson 3, is graph of rational functions, and also the new vocabulary word that you're gonna learn is about asymptotes, okay? So here's what the parent function of a rational function looks like. It looks like the red part right here. This is one function. It's the graph of f of x over 1 over x. You notice you see a fraction bar right there, so it's a rational function, and the x is in the denominator, and that's the parent function, and it looks like this. It is the red part right here. You can notice that it's not a continuous function. It's broken up. It looks like it's broken up into two different graphs. But this is one graph of a rational function. And rational functions have these things called asymptotes. Asymptotes are lines. They're invisible in space, like you can't see them, but it's basically where a graph gets closer and closer to but never touches it, okay? So on here, there's a vertical asymptote. Let me draw a dotted line here. We draw asymptotes using a dotted line, okay? So it looks like this. Okay, there's a vertical asymptote right there. And then there's a horizontal asymptote right here. It's basically, I like to look at it, it's just going in between the graphs, okay? And here's some more stuff that I wrote about vertical and horizontal asymptotes, but let me show you how do we find them using a Desmos calculator. Desmos, you know, it's really wonderful for graphing and analyzing graphs. So the question's asking you to find the horizontal asymptotes and vertical asymptotes. So let's look at the horizontal asymptote. So one thing you need to know about horizontal asymptote is that it's always going to be x equals, because horizontal lines, if you notice, any horizontal line crosses the x-axis. So well, that's why it's x equals, okay? And then for horizontal asymptote, is always going to be y equals, because horizontal lines always cross the y-axis here. So that's a little something that you can remember. Alright, so to find the asymptotes, we're going to just graph them. So we know that graphing is best done on Desmos. You can use the yellow calculators as well in the class, but I like using Desmos. So we're just going to type this up. Let me do a little split screen. Sorry, I'll get it together. Alright, and then I'm going to plug this in here. So you have 4 over, so I'm just going to get the division bar. To get the division, just hit the division symbol, and it splits it for you. So you have 4 in the numerator, and then in the denominator I have x minus 2. Here's my graph. Alright, so let's look at a vertical asymptote. Like I told you, vertical asymptotes x equals, and I'm just going to say it's over here, so I'm just going to guess it to be 2. So I'm going to write 2 here. X equals 2, and I guessed good. Sometimes like you might say, well, maybe it's x equals 4, and this is not an asymptote because it's actually going through the other graph. We want it to be in between the graphs. So like you can either zoom out, and then you just move this over to the left, and there you go, right there. Just make sure that it's between the two graphs. So x equals 2 is the vertical asymptote, because that's the vertical line. Let's look at the horizontal line. So horizontal asymptote, let me just take this off and put y equals. Let me guess it at 1. Okay, I'm going to say it's 1. Well, it's not it because it's going through the graph here. So I'm going to move it down to just place it in between the two graphs, and I'm going to say xy equals 0. That is the horizontal asymptote, y equals 0. Okay, so that's pretty much it. We will go, and then the graphs get a little bit more complicated, but it's still the same thing. So I'm going to graph this. You have 4 minus 2 minus 1. So I'm going to do minus 1. Then now let me look at, well, I have the horizontal line up here, so let me just, there you go. My horizontal asymptote is at y equals -1, and then my vertical asymptote is at x equals, I said 3, but that's not it. It looks like x equals 2. Okay. Let me go through some more complicated ones. Let's look at this one. All right. Let me take these off. Let me take this off. Let me bring my fraction bar. Or in the numerator, I have 2. In the denominator, I have x squared minus 4. Look at that weird looking graph. Well, this graph has 2 vertical asymptotes. There's one here at x equals -2. Yep, right there, x equals -2. And then the other one is at, let me move it over. It looks like +2. Yep, and x equals +2. And then let's look at the horizontal asymptote. y equals, let me check, maybe it's 0. Down a little. Look, it's kind of hard to tell because it's like, where is it? It's all of this is in between, but if you zoom out and then zoom, if you want the red line to get closer and closer to it, so if I move this up a little to 0, it gets, see that's, it looks like it's gonna touch it, but it's getting closer. See, it's not actually touching it. So I would say y equals 0 is a better guess for this asymptote.
Yeah, I'm holding.
Alright, so let's try this next function. I'm gonna do, oops. So in the numerator we have 3x minus 6. In the denominator we have x squared, whoops, minus 16. So I'm gonna hit this home button here so it takes me back to, oh, look at this graph. Alright, so let's look at the vertical asymptotes first. So it looks like we have 2 different vertical asymptotes. Remember, vertical is always x equals, okay? Let's try x equals -5. Nope, that's a little over to the left, so I'm going to move it over to the right. There. X equals -4 is an asymptote. Oops. Okay. X equals -4. And then the other one here is at x equals +4. So those are my 2 asymptotes. Now, horizontal asymptotes, let me see, I'm going to put y equals, and then I'm going to bring it down. Now, you see how it's crossing it here. So you want to know, well, is this a horizontal asymptote? It's still a horizontal asymptote because a horizontal asymptote, we only care about what's happening on the far left and far right. It is like your end behavior, okay? So here, if you look at y equals 0, and you see how it is, don't ignore the middle part, only look at the end behavior here. So here my horizontal asymptote is at y equals 0. And that does bring me to the next concept, which is end behavior. For rational functions, just know that end behavior is going to be the same thing as your horizontal asymptote. Okay, so for example number 9, let me go through here. If you can turn to that page, it's on page 20. To just graph it, so we're going to do, oops. integer. So you have 3 over x squared x squared minus 2x minus 8. Alright, and then looks like my horizontal asymptote is at y equals 0. So this is what my end behavior would be for this. You can say as x approaches positive infinity, f of x approaches 0. It's the same thing as your horizontal asymptote. And as x approaches negative infinity, f of x approaches 0 as well. Okay. Let me do the last example here. I'll plug it in. So you have in the numerator, you have x squared plus x, and then in the denominator you have x squared minus 36. Let's see, let's look at what my horizontal asymptote is. It's now y equals 0 because we want this green line to be closer and closer to my end behavior. So it looks like I need to move it up a little to 1 maybe? Yeah, it looks like the horizontal asymptote is at 1. So you just write, you can write the horizontal asymptote is at y equals 1, and this is what your end behavior looks like. It says as x approaches negative infinity, f of x approaches, we usually write infinity here or positive or negative, but we'd say is approaches the horizontal asymptote at 1. As x approaches positive infinity, f of x, I don't know why I'm just writing on slant like that, approaches 1 as well. It's just going to be the same thing. Both sides are going to be the same thing as your whatever you have here. So horizontal and vertical. Okay?